Yeah, good morning. This is Dr. Jayaprakash, Associate Professor and HOD, Department of Business Analytics. And today I will give you the brief review regarding the transportation problem in operations research. The transportation problem, the main objective of the transportation problem, the various homogeneous commodities that are initially stored at various origins to different destinations in such a way to minimize the overall transportation cost. And just that linear program problem, allocation models, and transportation problem and assignment problem, both are subclasses of linear program problem, subclasses of LPP. Yeah, the transportation, see, as you know that the homogeneous commodity or otherwise the production, any firm, or you can take it into consideration here, say, like for example, the cool drink manufacturing concern. And we have in India the largest plants, that only Coke and Pepsi, the largest brands, we have only Coke and Pepsi. And these companies, they have several plants located in different parts of the country. And the manufacturing product is absorbed by retail outlets, or directly you can transport to the wholesalers, or otherwise you can transport to the warehouses. And where you can start the plants, for example, these are all you can take into consideration origins. And from origins to different destinations, say for example it may be warehouses, or maybe wholesalers, or directly from the retail outlets. Those are the destinations. So for example, generally, if you take into consideration, for example, wholesalers may be origins, from wholesalers to different wholesalers in the country, or in a part, or in a region, whatever you take into consideration for the domain, from there to destinations, directly retail outlets. So the main objective here is the commodity, the product transport from origins to destinations to minimize the transportation cost. So you can see that this is the transportation problem is a fundamental optimization challenges in operation research. One of this is also one of the technique seeking to minimize the cost of distributing goods or services from multiple sources, that you call it as origins, to multiple destinations. So it involves determining the optimal allocation of resources to meet demand while minimizing expenses. Right now, see the transportation problems here. See, there may be balanced allocations or unbalanced transportation problems. Balanced or unbalanced, that depends upon only supply and demand, and total supply from various origins must be equivalent to total demand from various destinations. You simply say that. Okay, for example, if you denote as allocations at sigma AI, the availability, the amount available at various origins, we take into consideration sigma AI, and the amount required from various destinations, required or demand from various destinations, say for example Bj, sigma Bj. If sigma AI is equal to sigma Bj, that means total supply is equal to total demand. Then we simply call it as it is balanced transportation problem. And practically it may not. Supply may be more than demand, or demand may be sometimes more than supply. Such type of problems generally we call it as unbalanced transportation problem. Though it may be unbalanced, while if you are using some methods for solving the transportation solution, and that will be converted into balanced. For that, you have to allocate some dummy origin or dummy destinations you have to create, and therefore automatically convert into balanced. Now here we are talking about here, then balanced allocation means the transportation problem aims to balance supply and demand. As I already mentioned, if it is unbalanced, you have to balance it, ensuring efficient distribution. And the cost minimization. The key objective is to find the least cost method of transporting goods from origins to destinations. As I already mentioned, the main objective is to find the least cost, that is minimize the cost, right? Transporting goods from various origin to destinations. Where you can apply here the real life applications, you take into consideration anyway. Here it applications in logistics. We know very well logistics from different places to from different places, and supply chain management and resource allocations across industries we take into consideration. And formulation of the transportation problem. How to formulate the transportation problem? The objective function, you have to take it into objective function. The objective function is nothing but, here see, for that, decision variables. The key variables are the quantities to be shifted from each origin to each destination, to be transferred from ith origin to jth destination, for example. So each origin to each destination, that you denote as a decision variable. Say, for example, x1, x2, xn, and so on, xn, or it depends on that, like x, y, z, like that. And objective function, this is the total transportation cost which must be minimized. And we are able to form the transportation cost. Once you are able to form the transportation cost, that must be minimized. And for that, here the constraints for any problem, and allocation problem for any problem, either it may be maximize or minimize, depends upon the situation. And but here we talk about here the cost, because we have to minimize. But if you want to minimize the cost, and is always a restriction for that restriction here, constraints. That means these include supply and demand limits, as well as the capacity resources or restrictions. Capacity here, restriction based on that. What are the techniques to solve the transportation problem for initial basic feasible solution? There are two types of solutions we are talking about in transportation problem. One is IBFS, initial basic feasible solution. The second one is optimum solution. And let us take it as in this context we are talking about here the IBFS. There are three methods. One is the northwest corner rule, a simple but effective approach that starts in the northwest corner. That means topmost corner, leftmost corner to proceed towards the right lower corner, and systematically allocates supplies. And the least cost method, here see, it focuses only on minimize the cost of each individual shipment, building the solutions iteratively. But whereas Vogel's approximation method, a more advanced techniques that utilizes the optimum and quickly find near optimum solutions. And among these three, the best method is Vogel's approximation method. And why? Because in northwest corner rule, we are not taking into consideration cost. We start from one point and proceed towards the end point. And whereas in the least cost method, we focus only on least cost. It may not be feasible always. And whereas in Vogel's approximation method, for each origin, we take into consideration least and next to the least also. And based on that, that's why this is the more appropriate method for best method among those three. And see that northwest corner rule and systematic approach starts in the northwest corner of the transportation table and allocates supplies in a stepwise manner. And simple to implement. It is very simple to implement. So does not require complex calculations. Make it is straightforward and easy to apply and easy to understand. But here then suboptimal solutions. And while simple, the northwest corner method may not always yield the absolute minimum cost solution. It may not be considered as the best solution for that. And the second one is least cost method. And see here, and least cost method, it focused only on prioritize only the shipment with the lowest unit cost at each step. That is the, here say, every step we take into consideration in the entire matrix and identify the least cost, and allocation starts from that only. It is an iterative approach. So building the solutions gradually and making adjustments to minimize the total cost. But whereas the optimum outcomes can produce better solution than the northwest corner rule, but it may not also be optimum, nearer to optimum sometimes, but because we taken into consideration only least cost is the priority. And whereas Vogel's approximation method. So Vogel's approximation method, and among these uh, three methods, Vogel's is the best method. And see, approach is Vogel's approximation method leverages the concept of opportunity costs to guide the allocation process. Opportunity cost means least and next to the list also taken into difference and allocate, putting against each origin, and based on the destinations differences list to next list, and origins differences, among that you have to take into consideration and largest difference and go for the least cost allocations. That's why, and among these, and Vogel's approximation method is the best among that, and I try to, it is nothing but here I try to, the solution is built up through multiple rounds of optimization and adjustments. And that's why, and Vogel's approximation method, sometimes that itself is the optimum solution, or otherwise nearer to the optimum solution. Vogel's approximation solution is very close to the optimum solution, very close to optimum solution. While if you are using the optimum solution methods, and for initial basic feasible solution, but you have to find out initial IBFS from any one of the three methods. If you find IBFS by using northwestern corner rule, it takes more steps to reach the optimum solution. If you find optimum solution, initial basic feasible solution by using Vogel's approximation method, it reaches optimum. Sometimes it itself is the optimum, or otherwise it is very less steps you can reach the optimum solution, right? And then can finally can see that sensitive analysis and application says, that, and sensitive analysis here see evaluating the impact of changes in parameters on optimal solutions. Parameters means here the coefficient of the objective function, or otherwise constraints, and you are taking it into consideration for each constraints also, right side quantities or coefficients that you can change it, that you can take into consideration for the sensitive analysis part of it. And where is the real world applications? As I already mentioned earlier, transportation problem arise in logistics, supply chain management, resource allocations, and more and many more in industries. And continuous improvement, applying these techniques can lead to the significant cost savings and operational efficiency. These are only the initial basic feasible solutions. But if you want to calculate the final optimum solution, there are two methods, and MODI method, modified distribution method, and stepping stone method. And this is the basic for the transportation problem. Just introduction regarding the transportation problem. And thank you.